So in this video, we're going to look at what an inverse is and determine if there is an inverse of functions in different relations. But first, we want to talk about what an inverse is. And essentially, it's a function that will reverse another. So you think about multiplication and division. Those are inverse operations, addition, subtraction, and so on. Those are inverse operations as well. So in certain cases, we have a relationship where we can take one relation that maps to another relation, and if we can reverse that operation, then it has an inverse. But not everything does have an inverse. So what we first have to do is figure out two things. Is this a function? If it is a function, is it what's called one-to-one? Now, those are the two things that we're looking for. And depending on the relationship we have, there's different approaches we're going to take to find those out. So our goals today in this first video are going to be to look at inverses graphically with tables, so tabularly, and with equations analytically, and determine if they have an inverse. So first we're going to start off with graphs. But what we're going to do first is we're going to apply the vertical line test. And what the vertical line test is going to do is help us determine if we have a function. Then we're going to check if it's one-to-one by using the horizontal line test. Now, effectively what one-to-one is, it's almost like the exact opposite of a function. You're looking for any outputs that repeat with an input. So I can first apply the vertical line test. I'm actually going to do this in a different color so you can see the approach we're going to take. And it looks like here in the first one, I'm not really having any issues with it passing the vertical line test. Same thing with this second one and the third one. There's a lot of different places where things are working out pretty good. Number 4 is kind of the same as the other one, so I'm not worried too much about that one. If you look at like number 5, that looks like it definitely passes the vertical line test, and so does this one. We're having a lot of these relationships pass the vertical line test. Even here, we go through that point right there. It does cross twice, but that's an open circle, so it's not really there. It's more of a reference. But it looks like everything is passing the vertical line test. No matter where we go, there's only one. There's no place where we cross an output, or sorry, input multiple times. Then we apply the horizontal line test. Now this one's the same idea as the vertical line test. You're looking to see if it crosses multiple times. And this one looks like it's okay. So because it passes that, I'm going to say that yes, it does have an inverse. Say inverse exists. But if I look at number 2, when I start drawing for horizontal lines, see like right here, when I draw that one horizontal line, it crosses that graph twice. That's going to be a problem. What that tells me is that it's not one-to-one. So I'm going to say there is no inverse, not one-to-one. Fails the horizontal line test. If I go to a graph like number 6, it looks good. We're going to say the inverse exists. A graph like 7, don't think we have any problems with that one. The inverse exists. But when we go to 8, so if you look at it here, that's not a very good horizontal line. Let's try that again. Here we go. It's going to cross 1, 2, 3 places, so that's going to be a concern for us. So again, no inverse, not one-to-one. So for graphs, that's what we're looking for. Can we draw a vertical line so that it doesn't cross more than once? And can we draw a horizontal line to do the same thing? If there's any place where that test fails, then the inverse does not exist. So what about tables and other relationships? Well, here's the idea. We're looking for reversibility so that I can go one way and come back the other way. So if we look at this first relationship, January, February, March, July, these are 4 different months. Each of those goes to one season. But if I try to reverse winter, I don't know if I should go back to January or February. And so this one is no inverse because the output has a problem. We got it repeating input here. So no inverse because it's not 1 to 1. If I look at number 2, or this one up here, the table, I'm looking for, these are my inputs and these are my outputs. Any of these inputs give me a different output, I'm okay. But when I go to my outputs, that's going to be a concern because I've got that repeating one here of 2. And so that tells me that it is a function. I can go in this direction. 0 would tell me 5, 1 would tell me 2, and so on. But if I told you the output was 2, you wouldn't be able to tell me what the input is. And so for that reason, there is no inverse because it's not 1 to 1. If we look at this other mapping diagram, here's where we have a major breakdown. Actually, Ford and Bush, both of them are major breakdowns here. So we start with Ford. We've got two relations, president and vice president. So if I told you Gerald Ford, you wouldn't know if I was referring to him as a president or a vice president. If I told you George Bush, I'm assuming the first one, H.W. Bush, you wouldn't be able to tell me if he was president or vice president if I just said his name. We probably would think of him as president, but he was also a vice president as well. And the reverse is even worse because if I said president, I've got 4 different options. If I said vice president, I've got 2 different options. So there's no inverse. And I'm going to say for this one, because it's not a function, it's true that it's also not 1 to 1, but the first part of the test that I'm looking for is it a function? And that failed immediately. And with points, we're doing the same kind of thing. I'm looking for my inputs. I've got a 2, a 3, and a 1 with predictable outputs. We're okay. If I go with my outputs of 4, 2, and 5, again, predictable, no repeats. So the inverse exists. And for this diagram here, so we have, I'm sorry, collection of points. We have an input of 6, an 8, and then a 6 again with a different output. So this one is not a no inverse because it's not a function. It's got to be a function and also be 1 to 1. And then analytically, we're looking at equations. And here's the other thing we're looking for. If we have anything, quadratic, cubic, quartic, anything with a degree higher than 1, it will generally not be or have an inverse. They could be functions. All these things listed here potentially could be functions. But what the problem is that we have repeating outputs. I don't know what the input is. I can't work backwards and say, well, the output was 4, so my inverse is, or my input was 2. I can't do that. So this one right here is a quadratic. That's a problem. This is a parabola, but a little different one. It's a sideways parabola. That one won't actually be a function. This one here, same deal. And this one fails in a lot of different ways. That's the equation of a circle. So think about the graph of a circle. It's neither a function nor 1 to 1. Major concerns. There are ways, though, that we can make this work. And the ways we can make this work is we can take a quadratic like this, x squared plus 6x minus 4. So here's our full graph. And if we want it to have an inverse, we can essentially say, well, let's ignore this part right here. So the part that's going to give us a problem. What that is effectively doing is we're going to do something called restricting the domain so that it will have an inverse. But just as written, x squared plus 6x minus 4, there is no inverse.